Hey, how you doing, econ students? This is Jacob Clifford. Welcome to the Microeconomics Unit 3 summary video. In these videos, I cover all the concepts you need for your next quiz, unit exam, or final exam. Basically everything you need to get an A in the class. But it's a summary video, I'm gonna go pretty quick. This video is gonna cover Unit 3, production, cost, and perfect competition. Right now, it's time for you to download and print the study guide that goes along with this unit. It's inside my ultimate review packet, and the description is in the link below. I always tell my students that this unit is like taking off on an airplane. It starts easy with analyzing production, and you're just kind of speeding down the runway. Then you learn about the cost of production, which is when this course really starts to take flight. Then in a matter of seconds, you're way up there and analyzing and shifting the cost curves. The point is, jump on board and hold tight, or else you're gonna be waving goodbye to us from the airport. Let's start with a quick overview of the 5 big picture ideas you need to know for this unit. Number 1, the law of diminishing marginal return states that the additional output produced from hiring an additional worker will eventually decrease. Number 2, there are 4 per unit short run cost curves that you absolutely have to know: average fixed cost, average variable cost, average total cost, and marginal cost. Number 3, firms maximize profit when the marginal revenue equals the marginal cost. Number 4, firms in a perfectly competitive market are price takers because they produce identical products. They also face no barriers to entry and are efficient in the long run. And number 5, other firms enter a market if they can make profit and leave if they make losses. So in the long run, perfectly competitive firms earn no economic profit. That was just overview. Now let's go over the details. In topic 3.1, we're going to analyze the relationship between inputs and outputs. Your teacher or professor can use inputs like land or capital, but they're probably going to use labor. And they're going to start by giving you a chart like this. It shows the amount of output produced, let's say pizza, given the number of workers hired. So 1 worker can produce 10 pizzas, 2 workers together can produce 25 pizzas. The first thing you have to be able to do is calculate marginal product. This is the additional output produced when you hire just 1 more worker. But be careful here, the actual equation for marginal product is the change in total product divided by the change in inputs. When you have a chart like this and the number of workers is going up by 1, it's really easy to calculate. It's just the change in the total product. But you might see a question when a firm is hiring an additional 5 workers, and so just be careful. Whenever you're calculating marginal, you're looking at just 1 more, not 5 more or 10 more, just 1. Now your teacher or professor might also have you calculate average product. It's just the total product divided by the number of workers. It's super important for you to know the difference between marginal and average. In this case, the 5th worker produces an additional 1 pizza. That's the marginal product. But on average, 5 workers can produce 8 pizzas each. We can also take these same numbers and put them on a graph. This is the production function, and it visually shows the relationship between inputs and outputs. Now, before you took this class, you might have thought that when a pizza shop hires workers, the amount of pizza they can produce will continually go up. But this shows that that's not the case. The total number of pizzas produced as you hire more workers is going to increase at an increasing rate, then increase at a decreasing rate, then actually fall. And these are those 3 stages of returns. When you hire the 1st and 2nd worker, they can specialize and the total product increases at an increasing rate. So this is stage 1. But when you only have 1 oven or only 1 workstation, hiring more workers increases total product at a decreasing rate. This is stage 2, and it's not because these workers are lazy or stupid, it's because of fixed resources. This is the idea of the law of diminishing marginal returns. As you add variable resources to fixed resources, eventually the additional output's gonna fall. And at some point, as you keep hiring more workers, they start to get in each other's way and they're tripping over each other. This is stage 3. The marginal product is actually negative, causing the total product to go down. Again, the workers aren't stupid or lazy, there's just too many cooks in the kitchen.
Too many cooks, too many cooks, too many cooks, too many cooks.
Now, the one thing I want you to notice here is that so far we have not included any dollar signs. So far, we're not talking about how much it costs to produce a pizza or to hire workers. We're just looking at the relationship between inputs and outputs. We're gonna cover costs later. For now, make sure you can calculate marginal product and you can identify those 3 stages of returns. So take out your study guide and answer the questions for topic 3.1. Okay, here we go. In 3.2, we're jumping into the short run costs of production. Now this is tricky, so hold on tight. In the short run, every business has 2 types of costs. Fixed costs, like rent, don't change as you produce more output. So it doesn't matter if you produce 1 pizza or 100 pizzas, you always have to pay the same amount of rent in the short run. And variable costs change as you produce more output. These are things like electricity or labor or raw materials. The more you produce, the higher your costs. Here's what those look like on a graph. The total fixed cost doesn't change as you produce more output. The total variable cost goes up, but then dips because of specialization. And the total cost is just the fixed cost plus the variable costs. Again, these are the total cost curves. They're good to know, but they're not as important as the per unit cost curves.
Ladies and gentlemen, there is turbulence ahead.
Remember, there's 4 per unit cost curves that you absolutely have to learn: average fixed cost, average variable cost, average total cost, and marginal cost. The good news is that the first 3 are basically the same equation. Average fixed cost is the total fixed cost divided by quantity. Average variable cost is the total variable cost divided by quantity. And the average total cost is the total cost divided by quantity. The only one that's different is the marginal cost, but you already know that. Marginal cost is the additional cost of producing one more output. So it's the change in total cost divided by the change in output. It makes more sense when you see some numbers. Your teacher professor is going to show you a chart like this and give you the variable cost and the fixed cost. You don't have to make these up, they're gonna be given. Now remember, the fixed costs are fixed, so it's always the same amount no matter how much you produce. And the total cost is just the variable cost plus the fixed costs. These are the firm's total cost curves. These, on the other hand, are the per unit cost curves, the ones that are more important. In this case, the marginal cost is just the change in the total cost, so the first unit costs an additional $20. The second unit, additional $5, third, an additional $15, and the fourth, an additional $40. The average variable cost is the variable cost divided by quantity, so it's $20 divided by 1, $25 divided by 2, and $40 divided by 3. The average fixed cost is the fixed cost divided by the quantity, so $20 divided by 1, $20 divided by 2, $20 divided by 3. And you'll notice that it's an asymptote. It gets smaller and smaller, but never reaches 0. Also notice there are 2 ways to calculate the average total cost. You could use the same equation we just did by dividing the total cost by the quantity. But you can also add up the average variable cost and the average fixed cost. So you can calculate the average total cost of 4 units by dividing $100 by 4, or adding 20 plus 5. How you doing? Are you with me so far? You good? Now let's see what these costs look like on a graph. The marginal cost goes down, then up, like a Nike swoosh. We know the average fixed cost gets smaller and smaller, so it looks like this. Now this is the average variable cost. It goes down and up, and since the average total cost equals the average variable cost plus the average fixed cost, the ATC looks like this. These are the short run per unit cost curves. Now there's a few details that you have to watch out for. First is the shape of the cost curves. They happen for a reason. Marginal cost looks like a Nike swoosh because of the law of diminishing marginal returns. When you first hire workers, they can specialize. The additional cost of the units they produce are going to fall. But eventually, each worker is going to produce less additional output than the previous worker, so the additional costs of those units are going to increase. In other words, the marginal cost curve goes down and up because the marginal product curve goes up and down. Also remember that the average total cost and the average variable cost will always hit the marginal cost at their minimum. This is because when the marginal is below the average, it pulls the average down, and when the marginal is above the average, it pulls the average up. So mathematically, right here must be the minimum of the ATC curve. So if you draw or see a cost curve that looks like this, you know something is wrong.
Hold up. Wait a minute. Something ain't right.
And also remember that these cost curves can shift. For example, let's say the fixed cost increased from $20 up to $40. Pause the video and figure out which one of these columns is going to change. If fixed costs go up, then the fixed costs are going to go up, the total costs are going to go up, and so will the average fixed cost and the average total cost. But notice the average variable cost and the marginal cost don't change. But if there was a change in the variable cost, the marginal cost, average variable cost, and the average total cost would change. I know it doesn't seem like this matters much now, but trust me, it's gonna matter when we start talking about how many units to produce. Like everything else in this class, the best way to know if you're getting it is to do some practice questions. The study guide is gonna have you calculate, draw, and shift these cost curves. If you need more help, take a look at my other videos on YouTube, but right now, stop this video, take out your study guide, and do the questions in topic 3.2. Good luck. So far, we've talked about costs in the short run when at least one resource is fixed. For example, a pizza restaurant that only has 2 ovens. But now we're going to analyze the costs in the long run when all resources are variable and there's any number of combinations of ovens. The big takeaway here is that as firms increase the scale of the production, the average cost of producing each unit is going to decrease level off, and eventually increase. Again, this has nothing to do with fixed resources or the law of diminishing marginal returns. We're talking about the long-run costs. It'll make more sense with an example. Imagine a super small pizza restaurant that only has one worker and one oven. Since they're not producing very many pizzas, the average cost of each pizza is going to be relatively high. But a larger company that has 20 workers and 10 ovens can use mass production techniques like assembly lines and fancy robots. This is the idea of economies of scale. As firms increase the size of their business, the average cost per unit is going to fall. Now, at some point, the average cost per unit can't get any lower. This is called constant returns to scale. And eventually, it's possible the average cost for a pizza starts to increase. For example, if you're producing 20,000 pizzas a day in a huge factory, you might need your own generator or a cafeteria, and that's going to increase your cost. This is called diseconomies of scale. Now, we're going to come back to this in Unit 4, but right now it's important for you just to know what happens to the average cost per unit in the long run as firms get bigger and bigger. And right now, pause this video, take out your study guide, and answer the questions in topic 3.3. In topic 3.4, we're going to dive deeper into something that I talked about all the way back in Unit 1. Do you remember when I said explicit costs are those traditional out-of-pocket costs associated with making a decision? Implicit costs are those behind-the-scenes opportunity costs when you make a decision. As you know, profit equals total revenue minus total cost. But the question is, which cost should we include? If you're an accountant, then you would just include explicit costs, the traditional out-of-pocket costs. That would give you your accounting profit. But if you're an economist, you would include the explicit costs and the implicit costs, the value of your foregone income or time. This would give you your economic profit. Again, it'll make more sense with an example. So here's a practice question. Pause the video, see if you can calculate accounting profit and economic profit. Good luck. Avery's accounting profit is $50,000. It's the revenue minus just the explicit costs. Her economic profit is zero. Her total revenue equals all of her costs, including our explicit and implicit costs. So is making no economic profit bad? Well, not at all. Avery's covering all of her costs, including her opportunity costs, by running this coffee shop. And that's an important concept you're going to see in this class, the idea of zero economic profit or normal profit. Most firms in a competitive market are going to make no economic profit. They're going to cover their explicit costs, their implicit costs, but they're not going to make money up and above that. That's fine. They're making normal profit. Now, since this is an econ class, from now on, whenever you see costs, just assume they include explicit and implicit costs. So back when we calculated the short run average costs, those costs include opportunity costs. I bet you get it. So right now, pause this video and fill out the questions for topic 3.4 on your study guide. Let's hold up for a second. If this video is helping you, please do me a favor and give it a like and leave a comment below. I'm gonna read every single comment that you guys leave. And I know you're not gonna watch econ videos for the rest of your life, but please consider subscribing. It tells YouTube and other students that I'm doing a good job. I appreciate it. Thank you. In topic 3.5, you're gonna learn the single most important equation in this entire course, the profit maximizing rule. A firm will maximize profit when the marginal revenue equals the marginal cost, when the MR equals the MC. Again, let me explain with an example. Assume your side hustle is making homemade surfboards, and this chart is your total cost. If you can sell each surfboard for $800, how many should you make? The first step is to calculate the marginal cost, the additional cost of producing one more unit. And from there, you're just using marginal analysis. Keep producing as long as the marginal revenue is greater than the marginal cost. So you'd make the first, second, third, and the fourth, but you wouldn't produce the fifth surfboard. Producing 4 surfboards will maximize your profit. Easy, right? But keep a few things in mind. Notice the marginal revenue in this case doesn't actually equal the marginal cost. That's okay. Just think of the profit maximizing rule as a procedure. Keep producing as long as the marginal revenue is greater than the marginal cost. They don't have to equal. But what if they are equal? What if you sell a surfboard for $800 and the marginal cost was also $800? You don't earn any profit from that unit, right? No, you do. Remember that $800 includes your explicit and implicit costs. It includes your opportunity cost. Also, remember the profit maximizing rule is also the loss minimizing rule. If the price falls for surfboards, you should still produce where the MR equals MC, so you end up with the smallest loss. It's important that you see it on a graph, so here's a clip from one of my videos on YouTube that explains it best. Here's the marginal cost curve that you learned earlier. Notice it goes down and up because of the law of diminishing marginal return. And let's assume that you can sell every single pizza for $10. So the price is $10, and that's the same as the marginal revenue. Which makes sense if the price is $10 and the additional revenue that you get from each pizza is $10. But how many units should you make? If you stop producing right here, the additional revenue is greater than the additional cost. You can still get more profit if you produce more units. So you keep producing as long as the additional revenue is above the additional cost, and you stop right here. And you never produce over here where the additional cost is greater than the additional revenue. That's producing too much. You want to produce less back where MR equals MC. That's the profit maximizing quantity, and you're using the profit maximizing rule. Notice that I didn't even add an average total cost curve. You actually don't even need it to figure out the profit maximizing quantity. So whether the ATC is down here or up here, you're still going to produce where MR equals MC. I'll say it again, you don't need the ATC to figure out the profit maximizing quantity, but you do need it to actually calculate the profit. So let's say the ATC is down here and we're producing this quantity. The price times that quantity is the total revenue, which is that box, and the total cost is the average total cost times the quantity, which is that box. The difference between them is the profit, which is there. Because you're producing where MR equals MC, that is the biggest this box can possibly get. If you increase the quantity or decrease the quantity, the box is gonna get smaller. That's why it's called the profit maximizing rule. But if the ATC is up here, you're gonna be making a loss. But since you're making a loss anyways, it's best to produce where MR equals MC because the profit maximizing rule is also the loss minimizing rule. This is a loss, but it's the smallest possible loss that you can get. If you produce more output or less output, you're gonna end up with a bigger loss.
This part is pretty easy, but you still need to practice, so take out your study guide and do the questions in topic 3.5. In topic 3.6, you learned that there's one rule that trumps the profit maximizing rule. It is the shutdown rule. If the price continues to fall, at some point it makes more sense just to shut down and produce nothing. This doesn't mean that you sell all your tools and leave the industry. It just means that you shut down and produce nothing in the short run. You do this if you're losing more money from continuing to produce than if you would produce nothing and take your fixed costs like your rent as a loss. Again, it's important to see on a graph, so here's another clip from that video on YouTube.
To help you remember this idea, think of it like an inverted stoplight. Anytime the price is above here, above ATC, you're definitely gonna wanna produce because you're gonna make economic profit. And if there's low barriers to entry, other companies are gonna see you making profit and they're gonna wanna jump into the market. In the long run, other firms are gonna wanna jump into this market because they wanna make profit too, and that competition is gonna drive down the price, bring it down to here. But remember, this isn't a bad thing. Your total revenue covers both your explicit costs and your implicit costs. What happens if the price falls even further? It's not green, but it's still yellow, which means you keep producing, except you're making a loss. And when firms are making a loss, eventually some of those firms are gonna leave the market because they wanna go make money somewhere else, and that'll cause the price to go back up because there's less competition. And that'll put us back at no economic profit or normal profit in the long run. But what happens if the price keeps falling down? At what point do you just shut down and stop producing? Well, it's right here at the minimum AVC. If the price falls below that, you produce nothing, you shut down, you tell your workers to go home. And that's called the shutdown rule. To explain why, let's go back and look at the relationship between the cost curves. Remember, the difference between the average total cost and the average variable cost is the average fixed cost. And if that's the average fixed cost, then this box right here is the total fixed cost. This is the cost of your oven, your rent, and your insurance. Even if you produce no output, you're still gonna have to pay your fixed costs. When the price is below the average total cost, but above the average variable cost, you're gonna make a loss, but at least you're covering some of your fixed costs. But if the price keeps falling and falls below the average variable cost, then eventually that loss is gonna be bigger than your fixed costs. Instead of continuing to produce and having that huge loss, it makes more sense to shut down and take your fixed costs as your loss. So whenever the price falls below the minimum AVC, you should stop and produce nothing. You should shut down. Again, you're not leaving the market, you're just shutting down in the short run. So for competitive firms, the marginal cost curve above the average variable cost is the short run supply curve. As the price goes up, they produce more, and as the price falls, they produce less. But if it falls below a certain point, the minimum ABC, they shut down and produce nothing.
Let's make sure you get it. Pause this video and fill out the questions for topic 3.6 on your study guide. Okay, here we go. Topic 3.7. It's the last topic in this unit and by far the most difficult one. First, let's take a step back. In this course, you're going to learn about the 4 market structures. This unit's going to focus on perfect competition, and the next unit, unit 4, is going to focus on monopolies, oligopolies, and monopolistic competition. Each market structure has their own unique characteristics and graphs that you have to be able to draw and manipulate. Perfect competition is the most important one because if you understand this, you're going to understand all the other stuff we're going to learn later. A perfectly competitive market has many small firms that can easily enter or leave the industry. And each firm sells the exact same product. They're perfect substitutes for each other. This means that they are price takers. They have no control over the price and have to take the price set by the market. We already analyzed a competitive market in Unit 2 with supply and demand. This is the market for corn. Now let's see what an individual firm looks like in that market. So the market sets the price and each firm takes that price, leading to a horizontal or perfectly elastic demand curve. Now this equals the marginal revenue, right? The additional revenue from selling another unit is just the price of that next unit. This is what I mean when I said that the firms are price takers. Now we can add in a marginal cost and identify the profit maximizing quantity. A firm's gonna produce where the MR equals the MC. How much profit this firm's gonna earn depends on where the ATC goes. If it goes here, they're making profit. If it goes here, they're breaking even, earning no economic profit. And if it's here, they're making a loss. So this is it. I guarantee your teacher professor is gonna have you draw this side-by-side graphs showing a perfect competitive market and a firm making profit. But make sure you can also draw the firm making a loss and showing the idea of zero economic profit, where the total revenue equals the total cost. And this is the idea of long-run equilibrium. In the long run, perfectly competitive firms are gonna break even and make no economic profit. Remember, they're still gonna have positive accounting profit, but no economic profit. They're gonna earn normal profit. Again, to help you out, here's another clip from one of my YouTube videos.
So there's only 3 things that your teacher is going to ask you to do. Draw side-by-side graphs with a market and a firm making a profit, a firm making a loss, or a firm in long-run equilibrium. And they might ask you to draw what's going to happen in the long run if there's profit, or in the long run if there's a loss, or if we're already in the long run, what happens to get us in the short run, and then how do we get back to the long run? The point is you have to feel really comfortable drawing and shifting these side-by-side graphs. So if your teacher asks you to draw side-by-side graphs with the firm making a profit, you would draw this. There's profit being made, so in the long run, firms are gonna enter, the supply curve is gonna shift to the right, price is gonna go down, and we'll be in long run equilibrium. And if your teacher asks you to draw side-by-side graphs with a firm making a loss, it would look like this. In the long run, eventually firms would leave, supply would shift to the left, price would go up, and we'd be back in the long run. And if your teacher asks you to draw side-by-side graphs in the long run, it would start like this, and they say, okay, what would happen if the demand goes up for milk? The demand curve would shift to the right for the market, the price would go up for the individual firm, and they start making profit. Eventually, in the long run, other firms are gonna want some of that profit, so they're gonna jump into the market, causing the supply curve to shift to the right, putting us back in the long run. But this is assuming that this is a constant cost industry. This means when other firms entered the market, it didn't increase the price of milk machines and bottles and hay and other things you need to produce milk. Again, this is called a constant cost industry, and it's because the price didn't increase when other firms entered. It stayed exactly the same because the costs didn't go up. But let's do it again looking at an increasing cost industry. We start here in long run, there's no economic profit, demand goes up for milk, price goes up, now we're making profit in the short run. Firms realize there's profit, they want to jump in the market, but that increases the cost to all the other firms, increasing the price of milking machines and everything else, so the average total cost and the marginal costs go up, supply shifts to the right, but we're now at a new price that was higher than the original long-run equilibrium price. In other words, from long run to long run, the price didn't stay the same like a constant cost industry, the price increased. The vast majority of the time, your teacher's gonna have you draw a constant cost industry, but you should know about the other ones.
Now there's one more thing you have to learn here about perfect competition. In the long run, these firms are extremely efficient. There are 2 types of efficiency. The first one is we want firms to produce the right quantity of goods and services. In other words, we don't want them to produce too much corn or not enough corn. This is the idea of allocative efficiency. A firm is allocatively efficient when the price of the last unit they produce equals the marginal cost of producing that unit. Now, because perfectly competitive firms have a horizontal demand curve, they are allocatively efficient in the short run and in the long run. The profit maximizing quantity equals the quantity that society wants, or the socially optimal quantity. Again, the price of that unit equals the marginal cost. You might be a little confused on this right now. It'll make more sense when we get to monopolies and we look at firms that are not allocatively efficient. The second thing we want is for firms to produce at the lowest possible cost. This is called productive efficiency. Perfectly competitive firms are productively efficient in the long run because they're producing at the lowest ATC, the minimum point of the average total cost curve. But they're not productively efficient in the short run when there's a profit or a loss. They're not producing at the minimum ATC. But the big takeaway here is that perfectly competitive firms have both types of efficiency in the long run. Wow, I threw a whole lot at you, and there's a whole page in your study guide dedicated to this topic. Now it's time to practice. When you're done with your study guide, take a look at the exclusive Perfect Competition practice video inside the Ultimate Review Packet. But right now, pause this video and answer the questions in topic 3.7 in your study guide. Woo! That's it for Unit 3. Some students think it's the hardest unit in the course. Remember, if you need more help, do the multiple choice questions and the practice free responses in the Ultimate Review Packet. And be sure to watch the videos where I explain all the answers. And as always, thanks for watching. Until next time.